Thank you very much, Arash, for this excellent presentation. Now is the time for the panel discussion. So perhaps the audiences or the participants in this webinar could raise the hand and ask the question to our two speakers. So are there any questions from the participants? So either you can direct the talk in this meeting room, or you can drop your question in the chat box, and then I can read it and we can try to get the answer from the speakers. So of course, these two presentations today, so they are addressing one of the key points. So how the AI technology can be applicable to the application, either robotics or to the energy systems. And the first presentation by Professor Damian Ernst. So it's what's quite important from the energy market. So, Daniel, I have one curiosity to better understand from my knowledge. So, the one issue we have in the energy sector is the companies, because there are a lot of investors. There are a lot of basically the company they want to invest in this kind of the business. So now the point is that if the AI or the reinforcement learning, they bring some solutions. So basically for the energy, the trans sectors. So how the companies or how challenges the industry or the company will face to implement. So this kind of the technology is coming out of, or the solution coming out of the AI or the reinforcement learning. So I'm asking you from the industry side. So what kind of challenges they face? Okay.
Well, it's difficult for them, honestly, difficult for them. Why? Because they face, well, in every sector, let's say the decision-making problem that you face are very specific. In robotics, they are specific. Autonomous car driving, they are specific. If you want to, I don't know, control rockets, it's specific. And they are specific. So it's very, very rare that they can use off-the-shelf, artificial intelligence techniques for really making breakthrough in their field. They need to develop customized techniques. And for developing customized techniques, you need to have high-level people. Only high-level people are able to do it. And there is a kind of competition for talents between this industry and I would say the software industry, all these big AI giants, Microsoft, Google's, NVIDIA, and so on, so on. And sometimes, they do not offer salaries, which are big enough, to compete in terms of salaries, also for attracting these giants. So, in summary, it says for consequences that they have difficulties, to have the staff, required really for transforming their companies and tapping a lot on AI for improving the efficiency of their businesses. So this is one of the problem they face. Yes.
Okay, thank you. So, but Arash, I think you presented a very interesting case studies in your presentation. So, of course, you talk about some sort of the energy management EMS for the single car or the single agent. And because I want to find some similarity to the first speech, because you try to look at the torque management. So basically for the vehicle, and you try to see how to distribute the torque between the different the motors part. It means this is one of the cases we discussed. So in this context, because the dominant, he also presented about the AI, how to leverage the AI or the reinforcement learning for this kind of the energy, the distribution. So between the in some application like a smart grid. So my point is that how do you think that how the some techniques like the AI or the reinforcement learning so could give a benefits to, for example, to one of the cases like case one you mentioned. So what do you think about this kind of the technologies?
Yeah, I think it's a it's a challenging question, but it is my understanding. I would say that generally we have a problem that is formulated as an optimal control problem. This is a common problem between reinforcement learning and also, for example, model predictive control. So the common problem is that we have an optimal control problem, and the definition means that you have an optimization problem that has dynamics involved as well. And dynamics, in very simple words, are differential equations. Then it's shown that in order to solving it in most cases is not straightforward, then we approximate the solution of it. And model predictive control is one of the techniques to approximate the solution. And reinforcement learning is another technique for approximating its solution. They have lots of similarities, but a major focus of model predictive control is that you have a model, or you can have a good model of the system, but when you don't have a model, instead you have lots of data, then of course AI techniques are very effective. My experience is that for small systems that we are focusing, as you mentioned, standalone technique systems, in most cases we can have a model, or a good model, or but not necessarily, we don't necessarily have an established system to be able to get lots of data out of it. So in that cases, I think model predictive control is effective, which is based on the numerical solutions. But now we are working, for example, in our team on the data-driven techniques as well, direct data-driven techniques as well, either reinforcement learning or Krugman-based, to use directly the data instead of having a model of the systems. So I don't have a very clear answer to your question, but this is my understanding of the situation.
Yes, thank you very much. I think it's very clear to me. So, Damien, there is one question I think is related to your talk from the participant. So he's asking you what kind of tools you are using for simulation of the complex engineering system. So maybe if you have some ideas or something.
Yes, for the distribution grids, so the active network management grids, active network management schemes, we are using our own GIM simulator called GIM benchmark. So it's freely available, so they can use it. They can send me an email or access to the presentation, and there will be a link to the simulators. For the market, I mean, these are our own simulators, okay? Because you need for building these simulators, you need to have an history of the order books of the market, and we cannot make them publicly available. That's not possible. And let's say for the small problems about both sizing, so designing the environment and controlling it, all the benchmarks are freely available on GitHub. They need to go to the corresponding paper, and they will find a link to GitHub, or they can send me directly an email for additional information.
Okay, thank you very much, because I think the participant got the answer they did you. So I hope that the answer is sufficient. If not, maybe you could contact Professor Damien by email. So because of the time, so first thing that this webinar is live stream on the YouTube. I think later on you can get a link on the YouTube to find your speech. So because this is one basically the part for the journal already created on the YouTube channel. Okay, so based on the presentation today, so I would like to thank Professor Ernst for his excellent presentation, and also the Professor Moradinejad for giving a very informative presentation about EMS. So I would like to again thanks all of you, especially our distinguished speakers and also the participants for attending these webinars. As I mentioned before, so we are frequently organizing the webinar through the Journal of Complex Engineering Systems, and I will be happy to meet you again in the future webinars. And please also consider to submit your contribution to the journal. So at the end, thank you very much. I have no other point. Then just thank you again. Have a nice day and take care. And looking forward to meet you again in the future. Thank you.
Thank you.
Thank you. Thank you.
Okay.